Hello class, welcome to our lesson today dealing with section 7.3. This deals with what's known as the law of cosines. So up until this point, when we've dealt with the law of sines, we always had a ratio that was given to us, or we could find quickly, that had a side length and its corresponding angle that was across from it. The problem is not every situation has that, and so what we need to look at is some situations where that doesn't occur, where I would not have a given angle and corresponding side length, which is typically side angle side or side 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 types of triangles. Okay, the law of cosines is really just the Pythagorean theorem. It just, since it's not a right angle, this is where this extra piece comes from with the cosine aspect. Notice that whatever's on the left side, so it's a squared, and that corresponds to angle A at the end. It's basically just plug in everything and solve for the missing variable. If you have to use the law of cosines, you'll have to use it one time, and then you can go back to the law of sines in order to find your answers for the rest of a triangle. There's also another formula if you know three sides of a triangle in order to find the area, and it's known as Heron's formula. To find it, you find this constant s that's used in found by taking a plus b plus c, the three side lengths, and then dividing by 2 or multiplying by a half. And then once you have that s number that you found, it's that times s minus a times s minus b times s minus c, and it's square rooted. It's another way to find the area of a triangle if you know the three side lengths of the triangle instead of an angle and 2 of the side lengths. Okay, so here's the setup. I'm giving you angle C and side lengths A and B. You'll notice that those make a wedge all together. Remember when we did area, you could find the area of that triangle fairly easily with the law of sines formula. But the solving of the triangle is much more difficult. So you're going to have to use the law of cosines one time, and then you can use the law of sines after that. So I need to find side length C. So C squared equals A squared plus B squared minus 2 times A times C, and then cosine of the angle C. Now this is the easy version of the law of cosines because you literally just plug all of that into your calculator and find the answer. The most common mistake is when you find that answer, you have to make sure you square root it, because in order to find C, it's just like Pythagorean theorem, you got to square root your number. And then C is 2.83. From there, now I have side length C and angle C going together, so I can use those two together, and then equals, I'm going to find angle side length A, for example, is 4.21, and I can find sine of A. Do the law of sines, cross multiply that, and then when you divide out, you should get 0.705 if you take 4.21 times sine of 28.3, divide it by 2.83. And then don't forget, you have to do sine inverse in order to kind of find that answer, in order to figure out angle A. The other thing to keep track of here is if it is set up like this, where you have an angle and two side lengths, you want to find the smallest side length, smallest angle and smallest side length first after you've done the law of cosines. This is because there's no way that this angle A could be obtuse, because it has to be less than 90, because it's not the largest side length. If you would have solved for angle B first, you actually may have got the wrong answer, because when you plug it into your calculator, you're going to get an answer in quadrant 1. Well, it happens to be the answer in quadrant 2. So in this case, if you're given two side lengths and an angle between them, if you have to do the law of sines, you want to do the smaller angle first and the smaller side length, and then that leaves the leftovers by doing 180 minus the A value you found and the given C value in order to find angle B. That would be my suggestion to make sure you're getting more answers correct as you're looking at these questions. We'll use the same information, just do Heron's formula. So I just do 1/2 times of A plus B plus C, our newfound C that we just found. I get 6.375. I plug that in, times that minus A, times that minus B, times that minus C. Honestly, the most common mistake is you just plug something in wrong. I mean, I do that all the time when I'm plugging things in, a lot of numbers. It happens. You just want to make sure that you don't round these numbers off too early, so wait till the very end to round. And your homework will tell you what to round to find that answer. Okay, the other version that's needed for the law of cosines is when you have side, side, side. So notice I have side A, side B, side C. You'll notice that I chose to solve for angle B, and there's a particular reason for that. The only hope of there being an obtuse angle is angle B, because it's the largest side length. So if you have three side lengths, the one you want to solve for is the largest one first. The other thing that's difficult on this situation is you have to make sure that you do your order of operations correctly. So 10 squared equals 4 squared plus 8 squared minus 2 times 4 times 8, cosine of B. I'm going to subtract the 4 squared and the 8 squared to the other side because I got to isolate things. So I subtract those out, and I get 20. And then take 2 times, or negative 2 times 4 times 8, that's negative 64, and divide that out. And then cosine of b equals negative 20 over 46. Remember, anytime you have to find an angle, you do the inverse trig function. So you do cosine inverse in order to find that, and that's 108.2. From there, you can do law of sines. Sine of 108.2 over 10 equals, and I found c first. In this case, it's not going to matter which one you solve for. They're both going to be acute angles. There's no way those could be obtuse. And then that will give you 49.46, and A with subtraction from 180 would be 22.34. An important thing to make sure is once you find it, make sure the largest angle is the largest side length. The smallest angle goes with the smallest side length, which mine does. At least angle A is the smallest one. At least that makes logical sense in order to find that answer for this triangle. Again, the important thing on this scenario is making sure that you set this original part upright and do the order of operations correctly. A lot of mistakes are made with this negative 2 right here. Some people try to multiply all these pieces together, but you can't do that because the second part is being multiplied by the cosine of b. So those are some things that you want to think about as you're solving. Okay, so using Heron's formula, you have 3 side lengths. 1/2 times 4 plus 10 plus 8. This one is a rare occasion where it actually works out to be a fairly nice number. And then you plug it all in and you'll get 15.2. Don't forget to square root in order to find the area. But if you ever ask for an area question, please keep in mind that you don't have to solve the whole triangle. So I've seen students have a question like this, find the area using Heron's formula. They solve the triangle, waste 10 minutes or so trying to figure all these out because it takes a long time to write out and a long time to go through all those things. When in actuality, all they had to do was plug into this formula. So some ways to save some time would be to make sure you know what you're finding in those situations. This question, it's the idea of a surveying technique. So this is kind of an older idea, but it has been used historically to find the distance between 2 points where you can't really measure it. So here's A and B. We're trying to find the distance between them. They say from a point C, you're standing over here. The angle between them to go towards A and B, which you can measure, would be 46.3 degrees. And then the distance from A to C is 350. Distance from B to C is 286. You're trying to find the distance from A to B then using that information from that triangle. I called this side length C because that correlates to the idea that angle C is across from side length C. You can do it that way. And then it's just law of cosine. So it's c squared equals a squared plus b squared. It doesn't matter which one's a or b. It's kind of irrelevant. So don't focus too much on the a and b aspect of it, just knowing that it's those 2 side lengths. And then minus 2 times those 2 side lengths times cosine of the angle between them. Again, this is a good opportunity to use law of cosines because it's 2 side lengths and the angle between. You're not going to be able to use the law of sines in order to find this answer. This is the easier version of the law of cosines because you just plug all that stuff in on the right side, and once you find it, you square root it, and that will give you side length C. If you forget to square root this one, it's probably fairly obvious at this point because that number is going to be in the hundreds of thousands. It's going to be way too large to be the distance between 2 places if you've only gone 350 and 286 meters away from that spot. So, as you do application questions, make sure you know what you're solving for. So for example, if I wanted to solve for angle A, that would be solved additionally compared to having to find just side length C. It's a good way to save some time to make sure you know what you're finding. So don't just assume you have to solve the whole triangle in those situations. The other thing is sometimes in your homework, when you do have to solve everything, it might be in a different order than what you choose to do. So you might have to solve the whole thing, then plug in the pieces as well. Also, don't forget that you have to use the DMS feature in degrees, minutes, seconds at times if it asks you to use those. Most of those questions are around to the nearest 10 minutes, so you want to make sure that you're paying attention to that as you're plugging your answers in. Have a good day, everyone.